Every second of our lives, we are attacked by billions of bacteria, viruses, and fungi. The body has many ways of defending itself against pathogens. When a pathogen does infect the body, our body's defenses, called the immune system, are triggered and the pathogen is attacked and destroyed or overcome. Vaccine plays an important role in preparing and strengthening the immune system through introducing an antigen in the form of attenuated or weakened living virus that actively replicates in your body in order to generate immunity. Newer vaccines contain the blueprint for producing antigens rather than the antigen itself. Once the body produces antibodies in its primary response to an antigen, it also creates antibody-producing memory cells. This means that if the person is exposed to the dangerous pathogen in the future, their immune system or the antibodies can remember faster and more effective in responding immediately and kill it before it produces harm. This is what we call long-term adaptive immunity to pathogen. How long the protection lasts of these vaccines? Some vaccines like of COVID-19 vaccine can only protect for a short period and may need a booster doses. How do vaccine boosters work? Booster shots strengthen or maintain those immune responses to combat outbreaks and restore the protection which might decrease over a long period of time due to age and vulnerability. It needs to have a sufficient, prolonged protective immunity both individually and across the wider population. Booster doses often fill in those gaps. This figure shows B-cell responses to primary or initial vaccination and to antigen boosting. B-cells and T-cells are one of the types of immune or soldier cells. Vaccine-induced primary B-cells responded to the antigen. A germinal center reaction follows, which allows for the proliferation, reproduction, and selection of B-cells of increasing affinity for vaccine antigen. Antibodies produced at this initial stage of vaccination are usually of modest or in the moderate affinity despite of accumulation of high-affinity memory B-cells. This when vaccine booster plays a vital role, a time of boosting with a homologous antigen. High-affinity memory B-cells continually reproduce antibodies even in presence of persisting antibodies and compete for antigen with low-affinity naive B-cells. The final result is the production of antibodies of higher affinity. Always remember that when safety is first, you last. Thank you.